Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more. Momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John.
O'Reilly!
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Oh, I was doing a bit of a rockin' and bopping there to that introduction. I do love that. Welcome to Space Nuts, episode 266. I'm your host, Andrew Dunkley. Thank you for joining us once again. On this week's edition, a new way to measure the mass of a supermassive black hole. Last week, I told you about the thumb method. I think it's the same thing. We're also going to look at a few quick stories. The NASA moon mission looks like it'll be delayed, as will be the launch of Boeing's Starliner. It's got a flat tyre. And Mars Perseverance has failed in its first attempt to get dirt. It's not that difficult, people, but NASA is blaming Mars for the problem. We're also, it's not a question, it's a correction. We were talking about the issue with the ISS recently and that Russian probe that suddenly lit up and spun the ISS around. Mike DeRosa has contacted us to say he's recently discovered the show, but he's also got a very good explanation as to what happened with the ISS the other day. So can't wait to share that with you. And Matt from chat wants a dumbed-down version of dark matter. So we will do all of that today. And it is my great pleasure, as always, to introduce astronomer at large, Fred Watson, because I could not do this by myself. It would be very short. Hello, Fred.
Hi, Andrew. You'd make a cracking good job, actually. You've done 266 episodes of me spouting rubbish. You could do that. It's easy.
And you know what I've learned in 266 episodes? That we keep finding new questions without answers.
We do. That's what research is all about, and it's great.
Yes, indeed. How are you, Fred?
I'm very well, thank you. All good. Still in lockdown.
Yes. Well, we've had ours extended a bit, and I think it'll be extended again. It's supposed to end this week, but it won't, because we've got 139 cases in our region now, and quite a few of those are in Dubbo, where I am. And, they're trying desperately to haul it in. In fact, I got flagged by the health department as a casual contact, they call it. So I was at the same place at the same time as somebody who was infected. So I lined up for 3 hours yesterday to get my test, and I got the result at 3 o'clock this morning. They must stay up all night doing these tests, and I have a negative result. So I'm very happy about that. But yes, I think the hardest part for our government and the health department is getting people to do the right thing. The vast majority are, but they're just this handful of people that think the rules don't apply to them, and it's really causing trouble. And that's an issue all over the world. I mean, look at the lack of social distancing in Afghanistan right now. I mean, gosh. That's another difficult problem, isn't it? Anyway, Fred, we've got a lot to get through, so let us begin. A new way to measure the mass of a black hole, a supermassive black hole. Guessing the thumb theory is not going to do it again? Or look at the black holes. No.
There's more to it than that. You need two thumbs. It actually is it's something that is not intuitive. It's not something you'd expect to be the case. But let's just do the recap that supermassive black holes, are, we believe, in the centres of all galaxies, certainly most galaxies. But when we look back in time, as we can do in the world of astronomy, because light takes a finite time to reach us. When we look back billions of years, we find examples of what we call active galaxies, which have at their center a black hole that's consuming its surroundings very voraciously. And by that I mean that it has what's called an accretion disk. This is a disk of debris, gas, dust, probably a few old stars and solar systems thrown into it as well, swirling around the black hole. And it's that swirling that causes the energy that the accretion disk delivers. Basically, the accretion disk is bright in certain wavelengths of the spectrum because of this friction between all the bits of stuff. Now, what happens when you observe one of these distant and ancient, in fact, probably extinct now, actually, these active galaxies, which at their upper end are called quasars, by the way. The quasars are just the extreme examples of these active galaxies. What you see is in various different wavelength regimes, radio, infrared, you see a flickering of the brightness of the galaxy itself, the center of the galaxy. And this is we think it's due to the accretion disk having, it's an inhomogeneous mass of matter. It's got lumps in it. It's got stars in it. It's got dust and gas, which are quite smooth. But because it's swirling around, when a big bit goes into the black hole, we think that's when this thing brightens up and you get a bit of a bright flicker.
Like chucking a log on the fire.
That sort of thing. That's a really good analog, actually. Throwing a log on the fire, I like it. Now, so people have observed these flickers, for 30 or 40 years. We've seen them happening. I remember talking about these a long, long time ago when I was astronomer at the Royal Observatory in Edinburgh. And so the flickers have intrigued people. Is there anything we can learn from them? And it turns out that there is. And so this is science that has been carried out in one of the universities, University of Illinois, Urbana-Champaign. If I hope I'm pronouncing that correctly.
Champaign, yeah, I think you got that right.
Yeah, it's different spelling though.
Oh, okay. The name of my street, by the way.
Oh, is it? I didn't know that. Yes.
Yeah.
Is that spelled the Illinois way or the French way?
I think it's the French way.
Yeah, it probably is.
Yeah.
I would think so.
It wasn't supposed to be called that. It was supposed to be called King George's Drive. But because there was a St. George's Terrace on the other side of town, the ambulance service or the council decided it was too risky to have two streets with similar names in the same town just in case they went to the wrong place at opposite ends of town in an emergency. So we had to change it. But then I discovered there's two streets within a kilometre of each other just down the road that are almost identical in name.
There you go.
They missed that one. Anyway, I digress, as always.
So, yes, that's right. So, picking up the story again, there's a sort of pattern in these flickers. That's the bottom line. When you compare the flickers that take place over a short time scale with flickers that take place over a long time scale, which produce bigger brightness changes, and you can sort of balance these two together in a way that lets you discover what the mass of the black hole is in the middle. That's an extraordinary discovery.
Yeah.
That there is a signature, it's a fairly involved one, but that there is a signature in this flickering that reveals just what size of object you're dealing with. And I guess you can kind of relate to the question. If you think of what's happening, you've got, a bigger black hole is going to produce a much more energetic accretion disk than a smaller one. And so that would allow you to perhaps draw the notion that, yes, there are things in that flickering, because that comes from the accretion disk, that will give you some insight into the mass of the black hole. So these scientists, what they've done is they've done this for a number of galaxies with supermassive black holes whose mass is known, because there are other ways of determining the mass of a black hole. But it turns out that this one is extremely rigorous, if I can put it that way. It means you get a really good idea of the mass of the black hole in when you examine this flickering. It's a new diagnostic tool, if I can put it that way, for for scientists to examine the mass of a black hole by relatively straightforward means, just recording the flicker and look at the way these large-scale flickerings and small-scale flickerings relate to one another. And
so we're using all this high-tech, all these high-tech measurements of flickering and comparing black holes to the size of our sun.
Yeah, that's right. Well, we do, because we always give them in the mass of the sun, in terms of the mass of the sun. So a typical, I should have mentioned this, Andrew. Thank you for the reminder. A typical supermassive black hole will have a mass that is millions or billions of times the mass of the sun. The one in the center of our galaxy, which is a quiescent black hole, it's not doing any of this stuff, making flickers and the rest of it, but it is a black hole of about 4.1 million times the mass of the sun. That's a really quite modest one. These ones that we're talking about now have masses usually in billions of times the mass of the sun, so they're much bigger.
Okay. With this data, what would we be able to do in the future with this discovery?
It means there's a much more, in some ways, easily accessible way of determining the mass of a black hole. All you've got to do is observe the flickering over a period of time, probably a matter of months, and then analyse that, and you get the mass of the black hole, which is a really neat and tidy method that doesn't need some sophisticated algorithms to work it out. So yeah, it's very successful, and I'm delighted to say I've just looked down the list of authors of this work, and one of them is from my old alma mater, the University of St Andrews in Scotland.
Nice.
Scotland's oldest university.
Yes.
Founded in 1413, and I was there a few years later.
Also the world's oldest golf course.
Indeed, that's right.
Yeah. Royal St Andrews. Never had the pleasure. I would love to play there.
It's a nice place, yeah.
I don't think that's ever going to happen. Hard to get on, apparently. Got to go into a lottery and all sorts of weird stuff. Yeah. All right, that's good news that they're in a position to learn a little bit more about black holes, one of the great mysteries of the universe. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we have got quite a few things to deal with. 3 quick stories that probably won't end up being too quick at all because, we tend to chat. But first things first, NASA's planned moon mission looks like it might be delayed. And the problem isn't the moon, it isn't the spacecraft that's going there, it isn't the people that they would be sending or the things that they would be sending on the spacecraft, it's the spacesuits.
Isn't it? Yes, it's a bit, well, not exactly comical, but it's... I'm
thinking it's funny.
Yeah, it's a bit of a surprise that... there is an issue with the suits that are being designed, and they've been designed specifically for the Artemis program, which is the US-led mission to send astronauts back to the moon. Our schedule on that has been, the plan has been 2024 for the first landing. For some years now, I think it was the Trump administration that set that deadline. It was originally going to be later than that, but the Trump administration urged NASA to bring it forward, which they did. But it now looks as though it will actually be pushed back again, probably no sooner than 2025. And it's because of these... the development of new spacesuits, which have a vaguely Australian-related name, Andrew, which is Extravehicular Mobility Units, and the acronym is EMU.
Oh, of course.
It's the EMUs, otherwise known as spacesuits. And so there are delays. And there's been a report which I think is by Inspector General Paul Martin. I think this has come from external to NASA, but this report says that the delays are attributable to funding shortfalls, COVID-19 impacts, and technical challenges, and they have left no schedule margin for delivery of 2 flight-ready EMUs. These are the extravehicular mobility units.
The other problem, Fred, is that NASA sacked all its seamstresses a couple of years ago, so it caused a big problem.
Well, there's a story. Did we cover a story in that there are seamstresses, or there were in the early days of NASA, whose work on the spacesuits was actually revolutionary?
I think we did, and that might be why it popped into my head.
Why it popped into your head, yeah. So anyway, there's a huge. I think they've spent something well over 400 million for the development of these spacesuits. There is a slightly cheeky comment, which comes from somebody whose identity you'll guess, a tweet which said SpaceX could do it if need be, of course, from Elon Musk.
Yeah, of course. So
he's just put that in there, I think. But
we should get him on the program as a special guest.
I think it'd be great. I don't think
wouldn't it?
Yeah, I don't think he would stoop to space.
No, I think we're a bit too big for him.
Get the world's richest man on, Jeff Bezos, instead. How's that?
Why not?
Yeah.
Why not?
Anyway, all that rubbish notwithstanding, SpaceX is an integral part of the Artemis program anyway. But it is disappointing news. It's a shame that the delays are going to push this maybe to the very end of 2024 for the landing, but more likely to be 2025. And knowing the way these things go, you can guess it might be even later still.
Well, there's one spacesuit in a glass cabinet in Florida that I've seen that they know worked on the moon. Why can't they just grab that one? Neil won't mind.
Yeah, I suspect the old lunar, the Apollo spacesuits are probably a bit clunky compared with what Artemis requires. I think they want to do more work on the moon.
Judging by how often all the Apollo astronauts fell over on the moon,
exactly.
I'm guessing they were a little bit out of kilter with reality.
Yeah, indeed. Yeah,
but they worked.
They worked. That's right.
All right, from one delay to another, and that is the Starliner, the Boeing Starliner mission. Looks like it might be pushed back as well.
That's right. So Starliner was supposed to fly on
August
the 4th of August, yes, which is a date that I'll explain it to you one day, but it's regarded as Christmas Day in my household. August the 4th. There's a long story, which I haven't time to tell you.
Right.
Anyway, so we always joke about the 4th of August being Christmas Day. So there was supposed to be a launch 2.5 hours ahead of the launch. They aborted it, basically. And the bottom line is that it's not just something where you can tinker with the spacecraft while it's sitting on top of its Atlas V launch vehicle. It actually needs the Starliner space capsule, which, by the way, is Boeing's answer to SpaceX's Dragon capsule. It's the other of the commissioned human spaceflight capsules. It has to come off the Atlas V launch vehicle and go back to the company's factory, the Kennedy Space Center, for further work. And the reason is all about some valves which are sealed with Teflon, and they're in the thrusters that the Starliner uses. These are the things that, let you orientate the thing and keep it pointing in the right direction. And apparently, oxidizer has seeped into those seals, and the oxidizer that they use is nitrogen tetroxide, seeped into the Teflon seals, and you get a mixture of that nitrogen tetroxide with moisture, which creates something called nitric acid, which you don't really want because it will corrode the valves and basically makes them stick closed. And that's why they've had to take the spacecraft, either take the module off the launch vehicle and work on it in the processing facility.
What I want to know, Fred, is how the hell did they figure that out? I mean, 2.5 hours before launch, did a little light come up and say, this valve's going to stick?
I bet that's exactly what happened. Something like that. Anyway, it's probably in a computer somewhere. But these things are absolutely festooned with sensors to detect, what's happening, that everything's working. As they've got to be, because there's, with a spacecraft launch, you usually just get one chance at it. And if things go badly wrong, there's a lot of money gone down the drain. So, yes, so my guess is that it was not quite a red light, but something that would have certainly come up in the telemetry from the spacecraft. So, yes, it's pushed back. We don't yet have a date. It's even possible that it might not be before the end of the year. They're suggesting that maybe the first mission. This is actually, it's not the first one. It's the second test flight of Starliner. The first one ended badly too, because the spacecraft went into the wrong orbit when it actually reached orbit. It didn't dock with the space station, which is what it was supposed to do. This is the second mission. Looks as though it might be 2022 before it will take place. So another bit of a downer, really, Andrew. And I think you might have another one.
Better to be safe than sorry, though, Fred.
Yes, absolutely.
Yeah. Especially with safe than sorry. I will say though that Boeing isn't too disappointed to use the airport vernacular. They're very used to pushback.
Oh ho ho ho! Where do you find these things?
I don't know. The recesses of my dark mind.
Yes.
All right. From one disappointment to another, and back to this NASA problem. The first real hiccup of Perseverance. It's dug a hole and it couldn't get anything out.
Yeah, that's right. So Perseverance is uniquely equipped with a device that will collect samples for later return to Earth. So it's a little core sample drill. And the idea is it drills into rock and it pulls out a core sample, which is about the size of a piece of chalk, size and shape of a piece of chalk. If you can remember that, I can, and I hope many of our listeners.
Yeah, I can too.
Chalk pastels would be another way of looking at it. Something a bit about the size of your little finger, I guess, is the description, size and shape. That is supposed to be. Excuse me, Andrew. For the first time ever, I think I've sneezed live on Space Nuts.
It was a very delicate sneeze. Mine usually sound like a Boeing Starliner lifting off. So,
or not, as the case may be,
or not.
Anyway, it's supposed to drill into soil and lift that core sample back and put it in basically a sealed tube, which they then leave on the surface for a future mission to pick up. But what happened was the drill worked all right, but they didn't get anything out of it. It just came up empty. The drill, the sample drill that they use. So what is happening is that NASA is blaming Mars because everything worked properly, but they didn't get any material. It looks as though all the material that they drilled out was just really powdery rock, and so some of the material formed a little ridge around the hole, which Perseverance sent pictures back of, and some of it just fell back into the hole. And it's a bit odd, it's in many ways, I'm not sure whether people have drawn this connection before, but it's a little bit ironic because if you remember InSight, you and I talked about InSight many, many times with this thermometer that was supposed to be drilled a metre or so into the rock underneath it. And even by bashing it in with the, with the backhoe scoop that they had, they didn't get it in there. It was too tough. The rock was...
should have gone here.
Exactly. So they've had the opposite problem at Jezero Crater with Perseverance. One of the final comment is that I think Ingenuity has now had 11 flights, all of which have been incredibly successful. They've done aerial surveys now. They're really using this helicopter to make that mission value added in a way that perhaps wasn't really expected. So, yeah.
Unfortunately, unfortunately now Martian authorities are really getting upset about the obesity that's happening on Mars due to all these pizza deliveries. So it's a real worry. What impresses me is the photographs that Perseverance has taken to prove that it was the problem with Mars and not Perseverance, the little dust bowl it's created.
Yes,
you can see that so very clearly in high definition. It's a really good set of photographs
amazing,
of the powdery rock. They're going to have to find another rock, Fred.
A different rock, I think that's the answer. Yeah.
Yeah.
Maybe the drill was just too energetic, but whatever happened, they didn't get a core sample. And it must be a disappointment.
I'm sure they've got built-in systems to vary the drill rates and all that sort of stuff. I think they'll have it covered. It's just a glitch, people. Nothing to worry about here. But yes, we watch with interest and wait and hope that they do find what they're looking for. What are they looking for? Oh, evidence of past life.
That'll do.
Not very important at all, really.
No, it's a minor detail, yeah.
Anyway, we will, just put that one on hold and we'll get back to it soon. I'm sure there'll be another story very soon about the success of Perseverance digging a hole and collecting dirt.
I hope so.
Doesn't it sound inferior when you say it like that?
Yep, it does.
Yeah, never mind. This is the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson.
Space Nuts.
Now, I'm not sure I mentioned this last week because that's so long ago my brain doesn't want to go back there. But basically, you'll be pleased to know that the Space Nuts shop now has a dedicated URL, spacenutsshop.com. So it's really easy to find our shop and find all those amazing products that just continue to grow. And as I mentioned with young Ashley last week, we have now got stickers and shirts with the I'm a Space Nuts logo on them in various colours and designs. So pop along to spacenutsshop.com. Find something for yourself or your friend or your mum or your dad or your uncle or the dog. And, get it today. spacenutsshop.com is the place to go. Now, Fred, was it last week or the week before we were talking about the International Space Station and that little glitch with the Russian probe that docked and then for some inexplicable reason a software glitch fired its boosters and caused the ISS to swing out of position. Now, we said the alteration in its angle was 45 degrees, which is true, but it's not true. We've been contacted by Mike DeRosa, and Mike has a pretty solid explanation as to what happened. So I'll hand it over to Mike.
Hello, my name is Mike DeRosa, and I live in Manhattan in New York City. And I have a YouTube channel called Small Stars, where admittedly I don't talk as much about astronomy and planets as much as I would like. I kind of end up talking about space hardware and artificial gravity most of the time. But I love Space Nuts. I listen religiously. I never miss an episode. And I want to thank you guys for doing what you do and making my brain think about black holes, which is it's something else for my feeble human mind. So I wanted to give a correction from last week's episode. You guys said that the International Space Station rotated 45 degrees when there was an inadvertent thruster firing on the Nauka module. And this is, I guess, technically correct. And a lot of newspaper articles, reported the same thing. But it rotated more than 45 degrees. It's actually more like 720 degrees. It tumbled a couple of times. And it started out in a weird orientation anyway, because they had the Nauka module's port facing upwards towards the zenith direction. It's usually facing aft, in retrograde direction. But for the docking purposes, they flipped the station around, and then the thruster fired, and they couldn't turn it off, and it made the station spin a couple of times kind of uncontrollably. If you want to look at a visualization of it, check out Scott Manley's Twitter. It would be great to show on your visual podcast, I think. And if you can't find it, just email me. Thanks for everything that you do, guys. And maybe next time I'll ask an actual question.
Thank you, Mike. That's fabulous explanation of what happened. I did wonder how it could only rotate 45 degrees if the thrusters were going for however many minutes it was. But obviously, when they got it stable, it was 45 degrees off, and they had to put it back in place. But it sounds like it went round a few times as a consequence of that misfire. So thanks for the explanation, Mike, because we can only go on the information we have received. And like everybody else, the reports were saying 45 degrees. So we basically parroted that. But we didn't have the technical data that you obviously have access to, and well done on explaining it, because we want to be accurate. No, we don't. We want to be accurate. We want to be accurate. So we do not feel at all grieved by being able to put a correction on. We're not like those other foot-indoor journalists who think they're always right, even when they're not. Mike, and we'd love to get a question for you. So anytime, please send it through. And I'd love to listen to your podcast. So send me I'll get the name of it again in a minute, and I'll tune in. I've been listening to more and more podcasts lately. It's become a bit of a habit of mine now. I was stuck in that queue for 3 hours yesterday getting my COVID test. I listened to podcasts in the car while I was waiting to get up to the test station. So managed to get 2.5 episodes of a World War I podcast in while I was there. So, but nice to hear from you, Mike. Thank you so much for getting in touch, and thanks for being a fan of the show. Now, our first question, I suppose, first and last question for this week, comes from Matt in chat, as in Chattanooga. And he's got an interesting question that I think many of us would appreciate having answered.
Hi, this is Matt from Chattanooga, Tennessee. Hey, I just found your show, and I'm really enjoying it. And I'm working my way backwards, so you may have already answered this or covered this, but I haven't heard it yet. Could you guys do a really dumb version of dark matter? What is it? What does it mean? How does it work? Why is it important? I hear you talk about it on occasion, but I have no understanding of it. And typically you guys are really good at answering questions for people like me. But I would appreciate it. Thanks.
Thank you, Matt. Lovely to hear from you. A dumbed-down version of dark matter. Okay, you go outside at night, look up, and it's all black.
Nearly. That's very good, Andrew. Yeah. Do you want to leave it there, or
that'll do? That's a dumbed-down version, isn't it?
Well, it's a really interesting question, and it's not that hard to dumb it down because we don't really know what it is. And maybe the easiest way to deal with this is, and thanks for the question, Matt, is just to go through the history briefly, because it's quite an interesting story. The first person to notice that something was wrong was a Swiss-American astronomer called Fritz Zwicky, who was very active in the first part of the 20th century. And in 1933, he was observing galaxies in a cluster. Now, I must just pause there to tell you why astronomers really like Fritz Zwicky. And it's because he's
got a great name.
It is Zwicky. But he was somebody who didn't suffer fools gladly and had a way with words. And apparently he was once heard to describe some of his colleagues as spherical bastards. That was the term he used. Forgive the language. And when asked why they were spherical, he said, because they're bastards whichever way you look at them. And of course, a sphere is the only geometrical object that's like that. So, yeah, very nice stuff. Anyway, notwithstanding all that, in 1933, he discovered that galaxies in a cluster of galaxies in the constellation of Coma Berenices, that's in the northern sky, they were moving, the galaxies themselves were moving too quickly for the gravity of the cluster to hold it together. So they had velocities that were too high. The cluster should have disappeared, millennia ago, if I can put it that way. It shouldn't have still been intact. So he inferred that there was something invisible there, which he called dark matter, actually, in his paper. published a couple of years later. And this dark matter, whatever it was invisible, but had gravity, enough gravity to hold the cluster together. Astronomers kind of read the paper and really had no idea what to do with it and ignored it, basically. That was the bottom line. Until the 1970s. In 1970, the story comes to Australia with a colleague and good friend of mine, Ken Freeman, Professor Ken Freeman of the Australian National University, who was measuring the way galaxies rotate and how fast they rotate. And he realized that there was an issue, that galaxies are rotating too fast for what you can see to hold them together. There's not enough gravity there. So once again, it highlighted the fact that there was something wrong. Once again, nobody took any notice of it until 1978, when the definitive measurements of galaxy rotation were made by principally by Vera Rubin, very famous name in American astronomy, working with, and I can't remember his first name, Professor Ford, who built, I think, the instrument that Vera used. And they made really serious measurements of the rotation of galaxies and figured out that the only way that these galaxies could hold together was if they were embedded in a kind of halo, a sphere of something else, dark matter. And that was what really put the problem firmly on the map towards 1980, thereabouts. Since then, the quest has been to find out what it is. And one of the early, there were actually two candidate types of object which were proposed, and they were called machos and WIMPs. Naturally, machos are massive compact halo objects, and that means black holes or orphan planets or dead stars that don't shine. Stuff like that was littering the halo. That was the first idea. The second was WIMPs, weakly interacting massive particles. That's what it stands for. And that means a subatomic particle that has mass, but doesn't interact with any other particles. And in fact, experiments made during the 1990s, some of which were here in Australia, showed that it couldn't be the machos because they would register by a process called gravitational microlensing. We'd see their effect, and you don't. So from then on, from about 2000 on, people have just assumed that dark matter is some kind of weakly interacting massive particle, something that exists but is undetectable except by its gravity. And that's where we are now. There is one side story to this that I must mention, because one of its proponents is a keen fan of Space Nuts and he's almost certainly going to listen to this. And that is that maybe we've got gravity wrong. There's a theory called modified Newtonian dynamics, which was proposed by somebody called Mordechai Milgrom in about 1980, I think, not long after Vera Rubin's initial work. He's in Israel, and he built this theory that said if we've got the Newton's dynamical equation slightly wrong, if in particular, if at very low accelerations, such as those that are encountered by rotating galaxies or galaxies in clusters, far lower than the accelerations that you experience in the solar system. But if you've got an error at very low accelerations, things behave a little bit differently, then you can eliminate the dark matter problem because you can understand it from a dynamical point of view. But that has never found favour because it opens other cans of worms, and that's why people don't like it. Except Peter, who will probably be listening to this. Hi, Peter. Hope all's going well. Keep up the good work with MOND, Modified Newtonian Dynamics. It's entirely possible still that might be the way forward to try and understand what dark matter is, because the particle physicists who've worked very hard to find whatever these particles are have not actually come up with anything yet experimentally. Theoretically, they do see possibilities, but experimentally they haven't found anything. So I have to say my view of this leans towards the invisible subatomic particles, because there are other problems in particle physics that need them to be solved, not just the dark matter problem. I hope that explains what's going on, Matt, and why we're all so baffled by it. You're coming in with a great question. It's great just to revisit the issues surrounding the mysterious dark matter.
For the record, Matt, I thought my explanation was much, much better.
It's a lot more concise, I have to say that.
Well, it would have saved us a lot of time.
Yeah, it's dark outside you. I have to say, just following up on that, though, in many ways, one of the reasons why this puzzles everybody is that dark matter is a terrible name.
Yeah.
It should be called invisible matter. It's not dark at all. It's just that we don't see it by any means other than through its gravity.
Mm. All right, Matt, thank you. And being Australian and the land of nicknames, you will forever be known as Matt from Chat, whether you like it or not. So.
And if things get really bad, it'll be Matto from Chatto. That's
yeah, probably
truly
will be.
Australian, mate.
Yeah, that would be right. Yeah, and some of our nicknames tend not to be shorter than the real name because. I don't understand that. I always thought nicknames were supposed to be shorter, but I've had a few over the years. Most commonly, I get referred to as Dunks.
Yeah.
But there's been others. One of my golf partners calls me Slam Dunkley.
Oh, of course, yes.
Yeah.
I occasionally get Freddo, which is a good...
Freddo Frog.
That's pretty good. Yeah, it's good.
Freddo Frog is a chocolate confection that we have in Australia. I don't know if they're available overseas, but they're just chocolate frogs. But we, So that's my name for Freddo Frog.
Yeah.
Although they come in a strawberry version now, I think that's hideous. But anyway, that's a different story. Although if you run over a strawberry Freddo with your car, it looks the same as a dead frog. I don't know how we got onto that. Where did all that come from?
I don't know.
No idea. No idea.
Back where it belongs.
Yes, indeed. Too late. It's out there. Fred, by the way, if you have questions for Fred, you can certainly send them to us via our website, spacenutspodcast.com or spacenuts.io, and click on the AMA tab up the top and send us a text question. But on the very right-hand side of the screen, you'll see written laterally, send us your voice message. There you are. So you click on that and it'll take you to the recorder. So if you've got a device that can record or with a microphone, you can record your question in an audio form and send it to us because we love to hear your voices, and don't forget to tell us who you are and where you're from, just like Matt from Chat did. Fred, that brings us to the end. Thank you so much. It's always fun.
It's great, yeah, and thank you too for putting up with all our technical problems earlier today, Andrew.
Yeah, we should have a new segment called Let's Embarrass Fred. We got off to a very late start today because Fred's computer hadn't been updated since 1972, and because his computer's so old, it refused to update the browser. Yep. And so we couldn't get the interface working. But we eventually got it fixed with sticky tape and a couple of wads of spit, and it's all working at last. Yeah. Sorry, Fred, I couldn't help myself. But nice to talk to you. We'll catch you next week.
Sounds great. Thanks, Andrew. Take care. Look after yourself.
Professor Fred Watson, a very patient man and doesn't mind a little bit of a jibe. And from me, Andrew Dunkley, thanks for your company on this week's edition. Catch you again on the next show. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.